Hello, grade 10s. We are going to move forward today. Yesterday you were using SOH or sine, cosine, tan to solve for sides, and today we will use SOH to solve for angles, and that will pretty much be everything for this unit, except for some problem-solving questions. I should also mention that I did post solutions to number 9 and 11 from the homework from the second lesson. I had some questions about it from a few people. So those videos are posted. You can check that out on the YouTube channel, just like where the lessons are. Okay, so here's your first 5-minute question. Determine the lengths of x and y without using the Pythagorean theorem. I say this because once you get x or y, you could very easily use the Pythagorean theorem to find the third side, which is totally legit. But I would like you to use trigonometry both times here, just for practice. Okay, so I encourage you to pause it and try it now. Okay, so hopefully you paused it and figured them out. So here's our reference angle, and let's find side x first. So if we're going to find side x, well, that is our adjacent side, and we need a side. So we can't use y because then we have two unknowns, and that doesn't work very well. But here we have the opposite. Remember, it's all related to this angle here. So if we're dealing with the opposite and the adjacent, then we're dealing with tan. So tan of my angle equals the opposite divided by the adjacent. The variable is on the bottom, so I switch these, and x equals 3.2 divided by tan of 21 degrees. I go to the calculator, 3.2 divided by 21 tan. I hit equals, and I get that x is about 8.3. Okay, and I just look at the diagram to see if that makes sense. Yeah, that makes sense. And I just say it makes sense because it's longer than 3.2. And now we'll find y, and obviously side y being the hypotenuse should be longer than this one and longer than this one, but shorter than adding them together. So there's only a finite number of numbers, I suppose, that could fit there to one decimal place. Okay, so this is still our reference angle. We still have the opposite, but now we're looking for the hypotenuse. So if we're dealing with O and H, then it's sine. So sine of my angle equals the opposite, 3.2, divided by the hypotenuse, which is y. Again, variable on the bottom, so we have to switch, or cross multiply, as you might hear it called. I go to the calculator, 3.2 divided by 21 sine. And remember, if you have a two-line calculator, this will look a little bit different. And I get y is approximately 8.9 meters. And this should have been meters. So yeah, this side is longer than this one and longer than this one. And if you add these up, you get 11.5, which is which is longer than this, which makes sense because this line should be the direct root. And that's it. Okay, so that's your first 5-minute question. I can jump right into the lesson, which corresponds with your note. Yesterday, we developed a method for using trigonometry to solve for a side. Today, we are going to solve for an unknown angle. And this is very little new. The difference is that we're solving for an angle instead of a side, so you have to push an extra button on your calculator. So let's just get into it. Let's say we were looking for this angle. Okay? So if you're going to look for an angle, you need two sides. If you have an unknown angle, an unknown side, and only one side, well, you end up having two variables, so that's not going to work. So if this is my reference angle, this would be my opposite. This would be my hypotenuse. And if we look at old SOH, which you really should memorize, if nothing else in this unit, memorize SOH. O and H is sine. So sine of the angle, which in this case is theta, it's a Greek letter used for angles, don't let that freak you out, it's just a symbol like x or y, equals the opposite over the hypotenuse. And in one more step, we're done. And honestly, that's the whole lesson. So to do this, On a one-line calculator, which is what I have, first I do 3 divided by 3.9 and hit equals. Now, I can't just push sine of this number because that only works when we have the angle. So when we don't have the angle, theta is equal to the inverse sine of 3 over 3.9. Now, you don't need to worry too much about why this is the inverse. You'll learn a little bit more about it in grade 11. But for now, just know that if you're looking for the angle, you have to do the inverse sine, which basically means on your calculator, you would do second or shift sine. You hit this, and you get your answer, 50.3 degrees. So theta is approximately 50.3 degrees. Now you'll notice here I had something different written. So 3 divided by 3.9 is 0.769230769, blah, 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 blah. But instead of writing 0.77, I just kept this whole number. And I'm sure you can imagine why, right? It's more accurate. But if I just did 0.77 and then did second sine, I should get 50.3 or something very close. And I get 50.35, which would be 50.4. So in actual fact, this is the better way to do it. This step is something I used to do with students. And if students are really struggling, then I still do this. But do it in your calculator in one step. It'll save your writing, and it'll give you a better answer. So win-win. All right, so this is some other stuff I had for class, blah, blah, blah. Let's go to here. All right, so to access the inverse functions, most calculators require that you use the second function button, which is like shift or second, and then sine, or cos, or tan. If you have a two-line calculator, I will explain how that's going to look in a moment. So here we go. This is the angle we're looking for. We have the opposite. We have the hypotenuse. Let me go get my SOH. Oh. Sometimes this program doesn't like the copy and paste, but I got it this time. Okay, so O and H is sine again. So sine of the angle, in this case I don't know it, equals the opposite over the hypotenuse. And if you don't know what I'm doing, make sure you watch lesson 7.3. Now I go to the calculator. If you have a two-line calculator, you would do it like this. Shift, second sine of bracket 3.8 divided by 4.7 bracket equals, and you would have your answer already. Obviously that doesn't work on a one-line calculator. So just do this until you figure it out on your calculator. So for us one-line people, 3.8 divided by 4.7. And I do encourage you to use the calculator you will use next year, because otherwise next year is going to be unnecessarily difficult. So I divided the numbers, and then I do second sine, and I get theta equals approximately 54.0 degrees. And that's after I rounded to one decimal place. So this 5 would kick up the 9, which would kick up the 3. Okay? That's it. A few more examples and you'll have some homework. Number 2, use your calculator to figure out each one of these. So this is simple enough. Inverse sine of 0.5. On a two-line calculator, you would hit shift sine or second sine of 0.5. But on a one-line, you hit 0.5 first and then second sine. And I get 30 degrees. So 30 degrees. Remember, when you're doing inverse sine, you're finding an angle. So let's do cos. So 0.5 shift cos is 60 degrees. Inverse tan of 0.5, so 0.5 shift tan is 26.6 degrees. Oh, I forgot about the calculator check. To make sure you're doing this right, just do sine 45, and you get 0.707, and that works just fine. And finally, cos inverse of 0.62, so 0.62 shift cos, 51.7 degrees. Now, I want you to try this one without a calculator. Sometimes I'll put brackets. You don't need them, but some calculators you might. It just makes it cleaner. Again, you don't need them. Okay, without using a calculator, I want you to consider what would be the inverse tan of 1. So pause it and think about it. I think if you get this, you'll really have a really excellent grasp on what's going on here. So let me draw a triangle. Let's say this is our theta, okay? And let's say this side was 5. If our tan was 1, and this is the opposite, and this is the adjacent, if our tan was 1, then that means the opposite divided by the adjacent would be 1. 5 divided by what is 1? Well, 5 divided by 5 is 1. So this triangle, or they can make them 15 or 156, as long as these two numbers are the same, you'll get a tan of 1. Now, if I do inverse tan of 1, what do you think the answer will be? Again, I encourage you to pause it and try it out. The answer is 45 degrees. Now let's think about why that makes sense. If this is 45 degrees, this is 90, this would have to be 45 if you subtract from 180. Now tell me why that makes sense, or think about why that makes sense. Well, if these two sides are the same, then this is actually an isosceles triangle as well as a right triangle. These two sides are the same, so these two angles are the same. So it has to be 45. There's no other way. Now, if that made sense to you, that's awesome. If it didn't, you don't really need to understand that at this point. I'm just trying to help some people understand how these sine, cos, and tan things work. All right, solve for the unknown angle. I really would like you to pause it and try this now. Pause now. All right, this is our angle. This is our opposite side. We don't care about it. This is the adjacent. This is the hypotenuse. So if we have two sides, we can find an angle. We have A and H, which is C, or cos. So cos theta equals the adjacent divided by the hypotenuse. We go to the calculator. 20 divided by 45 equals shift cos 63.6 degrees. Now, you might think that that's approximate. You might think that this doesn't look quite right, and you would be correct. But look at the numbers here. If this is 20, this would obviously not be 45, right? This would be way higher. This would be way lower, or this would be way higher. These sides are very close in length, but the numbers don't match up. But don't worry about the diagrams. It's all about the numbers that you're given. Next one, 57, 80. We're solving for this angle. This is opposite. Again, you should pause and try this. This is hypotenuse. O and H is sine. Sine theta is 57 over 80. So I do 57 divided by 80 equals, and then I do shift sine, and I get 45.4 degrees. 45.4 degrees. Okay. Moving on. All right, here we go. Pause it and try it. This is my reference angle. This is my opposite. This is my adjacent. This is the hypotenuse. We don't care about it. So OA is tan, or TOA. So tan theta is 13 over 4. So 13 divided by 4 equals. And then I do shift tan, because I'm looking for an angle, and I get 72.9. Just like that. No more protractors. Next one, pause it and try it. This is my angle. This is my opposite. This is my hypotenuse. O and H goes with sine. Sine theta is 22 over 25. 22 divided by 25. Shift sine, 61.6 degrees. That's it. That's the whole lesson. So now you can find sides using sine, cos, and tan buttons. And now you can find angles using the shift sine, shift cos, and shift tan, or the second sine, second cos, second tan, or the inverse sine, inverse cos, inverse tan. Figure out what your calculator needs. If you can't, take a picture of it and send it to me, and I'll talk you through how to use it. Okay, folks, and as always, if you want more help, let me know. I'll set up a Google Meet. And if you want to not be the only one there, I'll put it on the classroom and we can have other people join as well. All right, take care.